Hi, I'm Ms. Wu. Today I'm going to introduce to you quadratic graphs. Example 1. What does y equals x squared look like? Let's draw a table and write down x values, and let's figure out what the y values will be. If x was negative 3 squared is 9. If x is negative 2, then y is equal to negative 2 squared, which is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. We can see that these values are almost mirror images of each other. Let's plot this. So here we have the graph. This is called a parabola. So this is what a quadratic graph looks like. Parabola is just its special name. And with each graph, we're going to analyze a few things. The y-intercept, so for this one, it's down here where it cuts the y-axis. The x-intercept, again, where it cuts the x-axis. And the axis of symmetry, which is the line that cuts the graph exactly in half. And then the turning point. The turning point is a point where the graph turns. So it's this point down here for this graph at 0, 0. Let's have a look at a few graphs so we get familiar with all these terms. Example 2. So for this graph, the y-intercept is right here, so where it cuts the y-axis, which is 0, 3. The x-intercept are the parts of the graph that cuts the x-axis, which are here and here, so 1, 0 and 3, 0. The axis of symmetry is where the graph is cut right in half. So that line there is where x is equal to 2. So it's an equation. Be very careful with that. X is equal to 2. The turning point of this graph can be read down there to negative 1. And we call this turning point a special name. If you look at the y values for the graph, so it goes from 3 to 1, smaller, smaller, and that's the smallest, negative 1, and then it starts to go up again. So we call this turning point a local minimum. Write that word down as well. Let's have a look at another graph. This graph has the y-intercept over here, 0, negative 3. The x-intercepts are 1, 0 and 3, 0. The axis of symmetry is here, x equals 2. And the turning point is now 2, 1. And this time, the turning point is a local maximum. So the biggest y value, so it's called local maximum. Couple things to remember for parabolas. This is a positive graph and that is a negative graph. If you forget, a really good trick is to draw eyes on them. Let me show you. See, this one looks positive and this one looks negative. When we have a positive graph, the turning point is said to be the local minimum. Whereas when we have a negative graph, the turning point is the local maximum. So pause the video and memorize these words, and I'm going to test you in example 4. Example 4. Here we have lots of graphs. So can you name which are positive and which are negative? And can you name which have a local minimum and which have a local maximum? So let's have a look at the first graph. We can see that, imagine eyes on them, that one is negative and it has a local maximum. That graph over there, again, I would imagine eyes next to it, or on top of it, sorry. And that is a positive graph and it has a local minimum. That one over there, again, a negative graph with a local maximum. And that one there, also a negative graph with a local maximum. Which of these are positive? That one. And which of these are negative? This one and that one. So the negative ones always have a local maximum and the positive one always has a local minimum. Example 5. You give this a go at describing this graph. Pause the video and unpause when you finish filling in all these details. So here we have the y-intercept at 0, 2.5. The x-intercepts are negative 5, 0 and -1, 0, and the axis of symmetry happens as x equals to -3, and the turning point is at -3 and -2, and it's called a local minimum. And this graph is said to be positive. One more example, you give this a go again, pause the video and unpause when you're ready to see my solutions. So the y-intercept is at 0, -5.5, and we notice that we don't have any x-intercept, so none. The axis of symmetry is at x equals 3. The turning point is at 3, -1, and is said to be a local maximum. And this graph is negative. Last example, again, pause the video and give it a go and unpause to see solutions. So the y-intercept is here, 0, 10. The x-intercept is here, 5, 0. And it happens to be the same point where the axis of symmetry goes through, x equals 5. And also it happens to be the same as the turning point, 5, 0. And this turning point is described to be a local minimum. And the graph is said to be positive. Thanks for watching. Make sure that you remember all these key terms, especially the pink ones, because I think they're new. And I'll see you in the next video. Bye!